Good afternoon, everyone. My name is Marco Paredes. I am with FIU's Earth and Environment Department, and today we're going to take a look at my research involving numerical simulations of tornadoes in tropical cyclones. Now, tornado production in landfalling tropical cyclones is actually quite common. About 7% of the US tornado count comes from these landfalling tropical cyclones. And what makes these tornado types so interesting compared to the typical mid-latitude case is that while they both require the same types of ingredients, convective available potential energy, moisture, shear, and so on, the tropical cyclone environment itself provides significantly less amount of these ingredients, and so the tornadoes that do manage to form are smaller than the mid-latitude case. But these smaller tornadoes still pose a significant threat towards coastal communities, as they can get quite powerful. Some of these tornadoes have been reported to get up to the EF3, EF4 range and devastate buildings that are in their way. That's why I find it prudent that research is conducted on these tornadoes and tropical cyclones in order to truly assess the threat that they are. My research wishes to look at what observations seems to show a preferred range of tornado production and see if it's truly valid. Here on the left, we have a distribution of known tornado locations from the TC Center. And as you can see, a greater number of tornadoes tend to form at the 200 to 400 kilometer range versus any other range. Observations alone will not be able to tell us why there's this disparity in ranges, so numerical simulations needs to be conducted. In this experiment, we conducted a real case simulation of Hurricane Ivan back in 2004, which was a prominent tornado producer, and used a six-way boxed resolution with about 8 kilometers grid resolution at the outermost box, going all the way down to a 30-meter resolution. With it, we were able to numerically simulate a tornado that you see here on the bottom. This was an outer core tornado in the rain band region of Hurricane Ivan right before it made landfall. And we've simulated its entire existence from its formation all the way to its decay. Next, we wish to change the environmental parameters surrounding this tornado to start mimicking the inner core environment of Hurricane Ivan and see which parameter is it that causes this tornado to form, and would it change if it had the inner core environment. This type of research will be very insightful because no other research has conducted a numerical simulation to this high of resolution, and again, observations alone won't be able to give us an insight into the hurricane dynamics and behavior, or the tornado dynamics and behavior. This research is currently ongoing, and I wish to see you all later in the future with more results. I'll be seeing you. Thank you so much for your time.